Hello, and in this video we're going to be using our logarithmic property to solve logarithmic equations. So let's review a little bit from what we've done already. We've already solved some basic logarithmic equations. Our methods were we have a logarithm that equals a number. What we would do is we would rewrite it in terms of the exponential form. We rewrite in exponential form. So that's our first step. If we have a problem where we have a logarithm equals a value, we would just convert it to logarithmic form, which would be 3. Here's our base, here's our exponent, logarithm equals the exponent, and that equals 2x minus 1. In this case we have 81 equals 2x minus 1, because that's what 3 to the 4th is, it's 81. We would add 1, get 82 equals 2x. So x is going to be 41 in this case. So we rewrite in exponential form and we solve for x. We're going to continue to do that in this part also, but we're going to use some of the properties to simplify the logarithms that we're going to find in these problems. So now what's going to happen is we're going to have more than one logarithm in our problem. More than one logarithm. So we have to use our properties to condense it down to one logarithm. So we're going to use our two properties, the sum one and the difference one. So here's my first example. We're going to use a sum problem. So this is going to end up being log. We're going to condense this down. So this means multiplication. So we're going to have x times x minus 21 equals 2. So we're going to end up with the log of x squared minus 21x equals 2. Now we're back to where we have the problem like we had up here in part 1. So we have one single logarithm. So we rewrite it. So it's going to be base is 10 here to the second power. Base is 10 to the second power equals x squared minus 21x. So this is going to be 100 equals x squared minus 21x. So we move the 100 over and we get a quadratic equation, x squared minus 21x minus 100. And let me think about that. I think we can factor this one. 25 times 4 I think works. So we have x minus 25 and x plus 4. Those two factors multiply together to give you negative 100, and they add to negative 21. That means that our two answers here for x are going to be x equals 25 or x equals negative 4. Now remember, in a logarithm, x values, we can only take the logarithms of positive answers. So putting 25 in here, we can take the log of 25 and we can take the log of 25 minus 21, which is 4. So this one is okay. Oops. But if we try to put in log of negative 4, we wouldn't be able to do log of negative 4. We would try to evaluate it and it'd give us an extraneous root. So our only answer here is going to be 25. Even though we got two answers by the quadratic formula. Okay, now let's look at their second example. This one, we're going to need to combine the two logarithms again together. But in this case, they're not together yet. So what we would need to do here is write it out so that we move this one by subtraction. If we subtract log x minus 3 from both sides of the equation, we're going to get this log of x minus 3 equals 1. So now we have it all on one side and we can now do our condensing format. So in this case it's a minus, so we're going to condense it in a division problem. So it's going to be 2x over x minus 3. So our condensing here is division, not multiplication, because of this being a minus sign instead of being a plus. So in this case, this is what we have. Now we're going to do our rewrite after we condense. Okay, we condense, we rewrite, so its base is 10, so we have 10 to the power of 1 equals 2x over x minus 3. Now we need to solve. All right, well, I'm going to multiply both sides by our denominator here to get rid of it on the right hand side. So we're going to multiply by x minus 3 on both sides. That reduces this side down to just 2x. Over here we get x minus 3 times 10, or 10x minus 30. We then subtract our 10x, so we're going to get negative 8x. Negative 8x equals negative 30. And then we divide, so we get 30 divided by 8, which reduces to 15 over 4, which is 3 and 3/4 for x. And we can use the positive 3 and 3/4 in here, because if we put positive 3 in here, or 3 and 3/4, we're going to get a positive log. We can take the logarithm of a positive number, and if we use it here also, 3 and 3/4, when we subtract 3, we still get a positive number. So we check that out to make sure it worked. It would work, and we can double check in our calculator to make sure it works, to see if it works by plugging it into our calculator. We would just take the log of 2 times 3 and 3/4, which would be 3.75 on a decimal. We would look at that answer, and we would then take a look at the answer on the right hand side to make sure they're the same. So we just take log of 3.75 minus 3 plus 1, and make sure that decimal, the two decimals here, are exactly the same in our calculator, so that we verify that that does work in the problem. So we verified that one. All right, so that's the algebra. So the next one here, we're going to have a little bit more algebra to do. The process is the same, but there might be some more algebra, so we're going to continue to do a couple more examples. This one we're going to need to add log base 5 of x minus 1 to both sides. Log base 5 of x minus 1 to both sides. So we're going to end up with log base 5 of x plus 3 plus log base 5 of x minus 1 equals 1. And then once we've done that, put them together, we condense. So once we condense this, we're going to have 1 log base 5. It's a sum, so that means we're going to have a product of x plus 3 and x minus 1. Product of those two things equals 1. Now we rewrite. Since we have one logarithm, we can rewrite. So we're going to have 5 to the first power equals x plus 3 times x minus 1. And now we have to solve, we're going to need to use FOIL or multiply here. And I'm going to use FOIL in my multiplication process to remember all 4 multiplications. X squared outside negative 1x, inside 3x. Last 2 is negative 3, and that's going to equal 5. So we're going to have x squared plus 2x minus 3 equals 5. We're going to then move our 5 over and get x squared plus 2x minus 8. And that does factor again. So we won't have to use a quadratic formula yet. We can factor this one. Oops, that's not what I want to do in factoring. So x minus 2 and x plus 4 are my factorizations of this. That'll give me, they multiply together to give me -8, and they add up to +2. So my two answers here, and I don't think both of them work, but my two answers are 2 or x equals -4, because we want to say x plus 4 equals 0, x minus 2 equals 0. So I think both of these are my solutions, but I have to check to make sure. Actually, this one will not work unless there's some sums here that are more than 4. I look back at original, I have +3 and -1. So this one will not work because it'll give us negative numbers. So if I have +3, add 3 to that, that's fine. If I subtract 1 from that, I'll be fine. So this one will work still. So my only solution is x equals 2 on that one. All right, now my final example here is using a natural logarithm. So we're going to have to use our calculator on this one because we won't be able to get an exact answer. There's not going to be factoring because this is going to be base e. So in base e, we're going to have some decimal as a part of our solution. So we condense this one just like we have it together. So we're going to condense first. So we write ln of x plus 1 times x, because it's plus, so it's times. All right, so we have ln of x squared plus x equals 2. Now we're going to rewrite, because we have one logarithm, so we're going to get e, that's the base, to the second equals x squared plus x. So this is a number. So we're going to move that over. It's going to go at the end, minus e squared. So that's our number. This is, and then we're going to have to use the quadratic formula, or we're not going to be able to factor this to find the solution. I'm just going to use a graphing calculator to figure out the solutions. So that's what I'm going to do here. I'm going to just graph this and find the intercepts. So I'm going to graph x squared plus x minus e squared. So I'm just going to type this in, and then I'm going to graph it. I'm going to push zoom 6, and I'm going to look and see if there's solutions. It looks like there are two solutions to this. Here are my two solutions, one here and one here. Okay, so I'm going to go second, calculate my 0 value, which is 2. Left bound, I want this one first, so I'm going to go over here, go left of crossing, right of crossing, and enter. So my first one here for x is approximately -3.26, which I probably won't use, 3.26, because that's a negative number. -3.264 is it to 3 decimal places. And then I'm going to take this second thing here and find my other answer. I'm thinking it'll be this other answer. Calculate the 0. Left bound, we want to move over here to this point. Enter, enter, enter. So we're saying here it's approximately 2.264. So x is approximately 2.264. Now, as I had before, these are not. This one's not going to work because it's a negative value, and we can't have a logarithm of a negative value. So my answer here is going to be about 2.264. This one's not going to be a solution. Okay, so that's our solution. Sometimes we have to use our calculator. It doesn't factor. We could also use the quadratic formula.